Okay, we're going to continue on and we're going to turn our addition machine into a simple calculator. So our calculator is going to have three functions: add, subtract, and multiply. So again, I've got an x and a y and a result, and so I'm going to need a way to input what the user wants to do. And so the way I'm going to choose to do this for this particular tutorial is I'm going to use something called an enum. So if I go to my modern tool palette and I'm going to hunt down my rings and enums palette, and I'm going to drop down something called an enum, and I'm going to rename this enum operation. And if I go into that, and I can add and remove items, but I'm just going to go edit all the items. So I'll right click and then go to edit items. Labview has a lot of functionality in the right click menu, and so I will create an item called add. I will create an item called subtract, and I will create an item called multiply. Ready? And now I have operations add, subtract, and multiply. If I come over here to my block diagram, I can actually highlight some stuff and make some more room. I'm going to need a way to now when I add, I'm going to want to make sure that I use the addition operation, and then same thing for subtract and multiply. And so sure enough, I can go and I can again come into my programming tool palette, and in numeric I've got a bunch of other options. So I can push the pin and keep these down, keep this around for a minute. I can pull out multiply and subtract because I know I'm going to need those. So the way that I'm going to use my enum to select which operator gets used is through a case structure. One way to do this would be I could have a separate input x and y for add, separate input x and y for subtract, but that's just going to be a real pain, and that's not the way the users are going to want to use a calculator in the first place. So I'm going to make a little bit of space, and I'm going to use case structure. And so what a case structure does is it allows me to select different cases based on an input. And so if I go into programming structures, and sure enough, toward the top here we have something called case structure. So I'm going to select that, and I'm going to drag it over just the plus. Again, just the addition operation. I'm going to leave the x and y and result outside. And if you dropped it down, you can actually right-click and remove, delete the case structure, and it will disappear, and we can recreate it. But that is actually not what I want to do. So my operation is going to determine which case I'm going to run. So if I wire operation up to the input, the case selector on my case structure, then actually I will get an add and subtract will pop up here, and which is great. The subtract case has the addition function in it, so I could remove this, delete some wires, move some things around, or again, when in doubt in Labview, right-click, and if I right-click, I can say, make this case add, and now add has the add in it. That's good. The subtract case, you'll notice the output tunnel is empty because it needs something, and so I can come down here, and I can wire up my subtract inside the case structure, wire that up. The program still won't run because well, we can run it and see, but it's because the multiply function isn't wired up. So I need to wire something in here. I only have an add and a subtract, but my enum, if I click him, I do have a multiply as well. So how do I get an extra case? Well, if I go in, there is a function add case for every value. That's probably what I want to use. I can also do add cases before and after. But if I highlight on subtract and say add case for every value, sure enough, I get another case called multiply. I can drag my multiplication operator in here. I can wire him up. And now my VI is ready to run. So 4 plus 5 is 9. Again, if I have to click run every time, if I don't want to do that, I can just click run continuously. Now it'll run all the time. So there's addition is working. How about subtraction? -1, -2, -3. And multiplication, 28, 21, 14. So my calculator, very simple calculator, seems to be working just fine. So that's a tutorial that gets us into some simple numerics, case structures, and using enums.